Isolation forest. Isolation forest is an ensemble method for anomaly detection that isolates anomalies rather than profiling normal data. The algorithm randomly selects a feature and a split value to partition the data, creating trees where anomalies are easier to isolate due to their sparse distribution. Anomalies are identified based on their shorter path lengths in the tree structure as they are isolated faster than the normal points. Let's go and implement this line by line in Python and see how we can build our isolation forest. We'll go ahead, and I've already created a file called as isolationforest.py. Here I'm going to first step is import the libraries. First sklearn.ensemble import isolation forest. This is where you can find it. Import numpy as np. So the first one, isolation forest, it imports the isolation forest class from sklearn ensemble, a widely used algorithm for anomaly detection. Now isolation forests are efficient for identifying outliers, as I mentioned, by isolating observations through random partitioning. Now numpy is used here to generate random data and handle arrays, something that we did in the previous algorithm too. So let's go ahead and generate sample data for training. So it's almost same as the last one, x equal to 0, 3 times np.random.randn 100, 2. If you have not heard about this in the previous video, I'm going to repeat this again. This generates a set of 100 two-dimension points randomly drawn from a normal distribution. They then scaled by 0.3. This scaling reduces the spread, creating points clustered around 0, 0. Now the x train np.r underscore x plus 2 comma x minus 2 forms two separate clusters by shifting points in x. The x plus 2 shifts all points by plus 2 in both dimensions, clustering them around 2 comma 2, whereas x minus 2 shifts all points by minus 2 in both dimensions, clustering them around minus 2 comma minus 2. The np.r underscore x plus 2 x minus 2 concatenates these two clusters vertically to create the x train. So let's go ahead and generate some test data with outliers. I'm going to say x underscore test np.r x plus 2 x minus 2 np.random uniform low equal to minus 6, high equal to plus 6, and size equal to 20 comma 2. This x test is combines the two clusters x in x plus 2 and x minus 2, same as the training data, with an additional set of 20 random outliers. Those are generated by that np.random.uniform, which generates 20 points randomly spread across a square region between minus 6 and 6 in each dimension. These points are more likely to be distant from the main clusters, making them potential outliers. Let's go ahead and initialize and train the model. First, I'm going to say model equal to isolation forest contamination equal to 0.1 and random state equal to 42. Now, this initializes the isolation forest model with contamination equal to 0.1, which specifies the proportion of data expected to be outliers. Setting it to 0.1 means the model assumes about 10% of the data points could be anomalies. Random state equal to 42 sets a random seed for reproducibility, ensuring that results remain consistent across runs. And we're going to fit the model. Trains the isolation forest model on X train data. Next, go ahead and make some predictions. So here I am going to say model.predict x test. This uses the trained model to predict on x underscore test. In the context of isolation forest, predictions of 1 indicate points classified as normal or inliers. Predictions of -1 indicate points classified as anomalies or outliers. Let's go ahead and print this out. Here we print the predictions where each element in the prediction array is either 1, which is normal, or -1, which is anomaly, based on the model's classification. This allows us to see which points in X test the model flagged as outliers. Let's go ahead and run this project. I'll save it. I'm going to open my command prompt and I'll say Python isolationforest.py, and there you go. We have our predictions depending on which points they were. Either they are outliers or inliers based on this. So I hope you are able to follow along and build this application or build this algorithm. If you had any issues, errors, or any questions, let me know and I'll get back to you.